All right, here we go with the Week 11 video. And remember, you can use this to check the work you did on your Week 11 test. You can also use it to study for Week 12 and for Week 13. So let's jump right in. Adding and subtracting fractions with like denominators. That's the first rule of doing anything with fractions. If you're going to add or subtract, you have to have a common denominator. So now that we have this common denominator, we're going to go through and we're going to use the diagrams to help us kind of figure this out. So we start with 11/8. So let's do this. 1, 2, 3, 4, 5, 6, 7, 8. That's 8/8. That's one whole. That's 1. And 9, 10, 11. So 11/8 is actually the same as 1 and 3/8. And we're taking away 5/8 from that. 1, 2, 3, 4, and 5. And I'm going to show that that's being taken away by just putting a red line through those. So we're taking those out. Well, if we're taking them out, then that means we're taking out these right here. That's the subtraction. We're subtracting these from this, which leaves us with 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6/8 left over. 6 out of 8. Now, this, let's just do the work up here also. So we have 11/8 minus 5/8. And I'm going to show it to you like this because really all the work happens in the numerator. So here again is where we have our 6/8. They tell us in the instructions, write your answer in simplest form. And if you don't do that, you don't get full credit. So how can we visualize that simplest form? Well, the easiest way that I have found to visualize it is if it can be lined up in 2 columns and each column has the same number of items, then you know, I'm going to draw a line right there, then you know that you can simplify this. Because instead of seeing it as 6/8, we can see it as 3 out of 4. And that's exactly what 6/8 simplifies to. It simplifies to 3/4. And there you go, Marge. 3/4. All right. Jump over to number 2. 3/10 plus 5/10. Well, just like the last one, all the action happens in the numerator. And we have 3 plus 5. That is 8/10. As far as our diagram, there's our 3/10. There's our 5/10. And when we get them together, there were the 3. 1, 2, 3, 4, 5. There are the 5. We can see we have 8/10. And just like last time, there are 2 columns here, and each column has 4/5, and that's the simplified version of 8/10. So our second answer is 4/5. On we move to problem number 2. Now in problem number 2, we've got that idea of when you multiply a negative times a positive, you're going to always get a negative answer. Excuse me. Let's do this table again real quickly. So if you have a positive times a positive, you get a positive. If you have a negative times a negative, you get a positive. Anytime the signs are the same, that answer is going to be positive. If you have a positive times a negative, that's going to be negative. If you have a negative times a positive, that's going to be negative. Different signs. So same signs positive, different signs negative. And that also holds true for all the division. So the same thing happens over here. If you have a positive dividing a positive, you get a positive. And if you have a negative divided by a negative, you get a positive. Anytime the signs are the same, positive. Same thing here. If you have a positive divided by a negative, that's going to be negative. And a negative divided by a positive also going to be negative. Same signs in multiplication or division, positive answer, different signs, negative answer. For this answer, we have a negative times a positive, so we know we're going to have a negative answer. 4 times 9 is 36. Down here, we have a negative divided by a negative. It's going to be a positive answer. 44 divided by 4 is 11. You can show it that way, or you could just show it as 11. Those same rules, think of all those rules we just did. Those are going to apply to all 4 of these problems. So m times n is equal to p. Here's the initial information they give us. We want to keep track of this. M times n equals p. One of the things we talked about in class was actually going through and assigning some numbers here. 4 times 2 equals 8. So you can think of it in terms of numbers. When we get down to the multiplication problem, part A, we're trying to get a negative answer. All right, opposite of p. Anytime we need a negative, over here are our 2 negative possibilities right there. Here are the 2 multiplication things that give us negatives. It has to be either positive times negative or negative times positive, which means for this, it is either the opposite of m, there's our negative, times n, there's our positive, or it is m times the opposite of n. That would also give us the opposite of p. For letter B, we're dividing something by a negative to get a positive. Something by a negative to get a positive. Something by a negative. Oh, we have to do a negative divided by a negative. And since p is the answer to m times n, then it's the opposite of p divided by n that equals m. Going back up to my numbers, it might help to think over here, well, 8 divided by 2 equals 4, so it has to be the opposite of 8, or negative 8, divided by negative 2 to get 4, since the signs have to be the same. Down to letter C, we're multiplying a negative times something, getting a positive. Signs have to be the same. That's negative m, or opposite of m. And finally, letter D, we're doing division again. We're getting a negative answer, opposite of n. So we know that one of these has to be positive and one of these has to be negative. Or it could be done this way to get opposite of n. The question then is which goes where, and think of it just like our numbers up here. If you wanted to get 2, the way you get 2 is to have 8 divided by 4. So it's either, oops, but we're not using the numbers, we're using our letters. So it's either positive p divided by the opposite of m, or it's opposite of p divided by the positive m. This is definitely something you want to review before the next test. You definitely want to study this, because this is one of the more complicated ideas. However, the good news is it's one of those things that once you understand it, it'll stick with you, and it's the whole idea behind why we're teaching this math. We're not teaching it so you can divide m's by n's and times p's and whatnot. We're teaching it so you can understand process. And then when you can learn how to understand process, you can apply that to so many things in life. All right, let's move on. So now we've got our tiles, and we're doing addition. Remember, we talked here about how you have to show the tiles. So here are our 6 positives, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. We're adding 2 negatives. That creates two 0 pairs. And we're left with positive 4. If you don't use the tiles, you're going to see this question again. If you don't use the tiles to model the problem, you can't get full credit. Simple as that. All right, number 7. We have -3 minus -2. Now, there are two ways to think about this problem. One is just to think of it just like it's written. You have 3 negatives, you're taking away 2 negatives, you end up with 1 negative. What would that look like modeled? Well, you have 3 negatives, and you take away 2 of them, you have 1 negative left. The other thing we've talked about doing is taking a problem like this and showing it as an addition problem. Instead of subtracting -2, we're adding +2. And now we can model that, -3 plus +2. That gives us these 2 0 pairs, and we're left with -1. 2 0 pairs. However you do it, you're going to get -1. However you do it, you also have to show some kind of modeling. All right, number 8. Fill in the box to make the statement true. We have something, we're adding -8, we want a positive number. Well, we need some number bigger than 8. Could be 9, could be 10, could be 50, but we have to have enough so that even after you cancel out 8 of them, you have positives left. Letter B, kind of the opposite idea. We have a positive, we have to add something and get a negative. Well, we need something less than -12.1. Let me rewrite that because it's kind of filling up the box there, and I don't want you to lose track of what I'm writing. We need something less than -12.1. You could have -13, you could have -14, you could have -100. There have to be enough negatives, though, so after all the positives get canceled out, there are still negatives left. Letter C. -1 and 1/5 take away something, making a positive. So we have to be taking away enough that we're taking away more than that, if that makes sense. So we have to take away. So this is one where you might want to stop and go, okay, what if I had, let's get rid of the fraction minute. What if I had -2 minus something, and I wanted to get a positive number? Well, if I take away 2, or take away 3, or take away 4, I just keep getting more and more negatives. I actually, in this case, I have to take away a negative, like -3, because that then becomes -2 plus 3, and that gives me +1. So in this case, I have to take away something that's actually less than the -1 and 1/5. If I took away -2, -3, -10, any of those work. In fact, let me show you -10. If I have -1 and 1/5, and I subtract -10, when I rewrite that, I've got -1 and 1/5 plus +10, and now I'm going to have -1 and 1/5 0 pairs. They're going to cancel out part of that, and they're going to leave a bunch of positives left. And finally, letter D. If you want to take something away from something and get 0, you have to take away that amount. 9, take away 9 makes 0. Now, if you put -9, here's what you were thinking. You were thinking of 9 plus what equals 0. And yes, if you want to add to 9 to get 0, you have to add the opposite. If you're subtracting, you have to take the 9 away. All right, we're nearing the end here. So number 9, what's the distance between 5, 8 and 5, -6? Well, we have, this is creating a coordinate plane. So let's draw our coordinate plane. There are the x's. Here are the y's. Every time you have a number like this, a coordinate pair, it's in the form of x then y. So 5 on the x, 8 on the y. There's going to be an 8 right up here, 5 out here. There's your first point right there, the point. 5, 8. 8. Not a very good 8, is it? Let's make that a better 8. The pen's writing kind of thick today. That's a better 8. And our second point, 5, negative 6, that's also the x and the y. So I already have the x for 5. Here's the negative 6 on the y-axis. So I'm going to have another point right down here for 5, negative 6. And the distance right here between these two is 8, 8 down to 0. And the difference between these two, let me move that line over just a little bit. Move the line off to the side there. And the difference between those two is 6. So the total difference is 14 units. That's our answer to number 9. Number 10. Sarah made a map of her house. Each unit represents 1 mile. She's traveling first between the distance from her house to the farm. So here's her house, and here's the farm, and we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 miles. 10 miles to get from the house to the farm. We have to walk past the gym. And what's the distance between the gym and the park? We walk 1, 2, 3, 4, 5, 6, 7, 8 miles. If you're coming up with one more than the answer, if that one, for example, you got 9, then you made your first count here. You went 1, 2, 3, 4. That's not how it works. It's 1. You're actually counting. When you're doing this, what you're actually counting is that little space, and that little space, and that little space. It's the space between the lines. Think of it as when you take a step, the step isn't how far you go isn't how many times your feet go down. It's how far your feet go. All right. To the end here. Which one of these has the same answer? Well, 3/8 plus 1/8 is 4/8, which is the same as 1/2. Which of these are a half? Well, not this one. That's 7/9. How about this one? 3/6. Yep, simplifies to a half. Bing, 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 bing. How about this one? 4/10, which simplifies to 2/5. Some people picked C. They thought that was going to be a 5 instead of a 4. And then here, 8/12, which simplifies to 2/3. All right, there's your Unit 11 test. Do some studying, please. Review these before you come into the next test. It's amazing how just a little bit of review will help you avoid some silly mistakes. And I will see you in class.